I am Kundan Kumar Yadav and I am going to explain about the splitting of the code using Webpack. So code splitting is all about the breaking our application's code into a smaller and more manageable chunks and loading them only when they are needed. This approach reduces the initial load time of our web applications, enhancing user experience, especially on slower network connections and less capable devices. It also facilitates more efficient use of the browser caching. So in this whole session, we will proceed with the Webpack. So here you can see on the left side, these are the .js files, .css files and .png files. They are interlinked to each other and they are whole bundled and moduled into single file, and they are put into this bundler. This is called bundler, and after this bundling they are divided into a small chunks. So these are a small chunks such as index.html, index bundle.js. These files sizes are very small. So what is the definition of the code splitting? So code splitting is just dividing the larger code into a smaller and more manageable pieces. Instead of loading all the pieces at once when you need a web page, code splitting lets you load only the pieces you need right now. This makes web page to load faster and to work better, especially when there is our slow internet connection. Then it is very helpful. So what are the advantages of code splitting? You can see first advantage is faster initial page load. As you can see, our page will be loaded as when we need the only the portion of that code will be loaded. Second is improved performance. Third is reduced bandwidth. Instead of bringing the large modules of codes, we can bring the small chunks. It will require very less bandwidth. Enhanced caching. In our browser, the small pieces of the codes will be stored in the small cache of our browser. And better search engine optimization. The code splitting also improves our search engine optimization, which helps in fetching our website very faster. So let us dive into the implementation of the code using the Webpack. So we will introduce about the Webpack. So earlier I discussed about the bundler. This is the bundler and it is called Webpack. It is a module bundler in which they all files are stored as a module or a large bundle, and after that they are splitted into different files such as .js, .png and .css. um, According to our need, we only load or fetch the required files. So this is our Webpack, which we are going to discuss about that. Webpack is just like um, a super smart builder for web applications. It takes all your websites code and assets such as JavaScript, HTML, CSS, and organizes them very efficiently. It can also do helpful things like making code smaller for faster reloading, for faster loading and optimizing images, and managing dependencies between different parts of your web project. So, steps for implementation. First step is to create a folder, and second is initialize using npm init -y, and third stage is third step is to install webpack and the web cli using these commands, and fifth step is to structure our folders in such a way as in the figure: index.js, page1.js, page2.js, etc. And sixth step is to create we are going to create two additional pages, page1.js and page2.js, which will be dynamically loaded by using the document.get element by id. And seventh step is our creating index.html file, which is used to load the JavaScript portion into the browser. And eighth step is to configure our webpack configure.js file, which where you can see the many things such as entry entry points or entry files. So I would like to define what is the entry. So entry, these entry points are the JavaScript files where webpack starts building your application. Here are three entry files: main, page 1, page 2, and output file. This is the place where webpacks outputs the result. And third is optimization. What is optimization? This property allows you to configure webpack's optimization options. In this configuration, we have used a split chunk option, and this a split chunk option tells webpack to split chunks for all entry points. It enables code splitting for all chunks, which means that common dependencies shared among different entry points will be extracted into separate chunks to optimize caching and reduce duplications. So we known about all the components of the webpack.config.js. Now we proceed to build our project, and we build our project, and then we will start our server, and the result will be affected on the browser side. Now we are going for the further actual implementation using the TypeScript. So we need to install these packages such as types, load-as, react dom. So this is our package.json file. After installing all the dependencies, you can see here all the dependencies which we installed earlier. This is our page1 page.txt file, tsx file. It is a TypeScript file which is rendered on the root file. Root is also a file. Here you can see console filter is used, and it returns the array which contains the string 1, which is used for filtering. Here is page2.txt file, tsx file, and you can see here our entry points again in the webpack.config.js file. So in this there are two entries file. First of all, we are creating two entries file where webpack will so in this there is a module file, and this is a regular expression which is showing that these are all txt files, regular expression for .tsx files. So we, after configuring this file, we are going to build this file using npm run build .prod command, and on the terminal we will see the following things: page 2, page 1, bundle.js, and these sizes are provided at 99.6 KIV, 169 KIV. So these are chunks. After dividing the whole bundle into two chunks, these are the outputs, our outputs. So earlier we discussed about the optimization. What is optimization? So we are again going to discuss about the optimization. Suppose there are several reasons that we would not like to have all of the React code in every bundle that we create. Whatever the bundle we have created, we don't need to keep all the React codes in every bundles. So one of them, for example, is it severely impacts our ability to cache bundles. When compared to our code, the third-party code that we use is probably updated far less frequently, but every time we update our code, then a new bundle will be generated, and then the user will have to reload and reload a lot of code that has not been changed earlier. So in order to fix this, again we need to update our webpack using the optimization technique. You can see here optimization, in which there are different split chunks, and in this split chunks there are cache groups. As optimization is a variable here, it is exported after doing these changes. After configuring, it tells that all the modules, node module files, are stored as the chunks in the commons, as name as commons. So after building that, we can see the result here, common.bundle.js, which is of very larger size, as we know that node module is very larger size. Next, again we are, suppose if we don't want node modules to contain whole the React and all the non-React files, then we divide into two parts. First is React and second is commons. So in React we are storing all the files which contains all React into the node modules, and common files store all the non-React files which does not contain any React file. After building this, we can see the result here. There are four files here, four chunks here. First is react.bundle.js, which is 95.8 KIV. Second is 72.5, and these are page 2 and page 1. So finally we came to the conclusion that our large module is divided into different chunks, and there are four chunks of a smaller size. So on the concluding that smaller files are loaded easier, and whatever the files and what we need, then they are only browsed. So our browsing becomes very faster, and the bandwidth are reduced because of this very less size of files. So thank you. That's all about. Thank you, team.